Hi, I'm Daniel. I'm an integrations engineer on the enterprise applications team here at GitLab. I'm going to walk you through the Platypus integrations platform that we've built in the integrations team and how it solves common business problems that we have here at GitLab. But before we jump into Platypus, I want to take you very quickly through some integrations theory and why we need an integrations platform and why we chose the technologies that we did for Platypus. So current integrations that we see here across the business today. System A needs to send some data to System B, and this could be bidirectional, where B needs to send data to System A as well. This might seem pretty clean and straightforward, but there are some downsides. Often we see these set up by system DRI teams or vendors that we engage. Many are not actively supported or monitored by anybody, not the vendors, not someone internally. And even when they are, sometimes that is extremely limited. It's basically invisible to AppSec, legal, and internal audit teams. It's kind of a self-reporting type situation, and people don't necessarily do that. They don't necessarily know that they need to do that. And often they're not fully configured or correctly configured, and because of that, they might have gotten a bit out of date, and they require manual intervention or manual steps every time they run by these teams, which takes up time and resources. And then what we see for more complicated single source of truth applications, and more realistically with all the different applications we have in our ecosystem, is something that looks more like this. So we have a lot of point-to-point integrations between different systems where systems have to talk to a lot of other systems in order to get a full picture or to be able to send data around the ecosystem of applications we have here at GitLab. And you might think I made this up, this diagram, but this is actually a real diagram of systems that we have today at GitLab for the order to cache process. And then I've highlighted here which ones of these systems are single source of truth systems. So we have Zora Billing, which is the owner of subscription data, of customer billing information and accounts. We have Salesforce, who are the owners of the leads and the contacts for different people we engage, different customers we engage, and also Customers. Which is an owner of license data and also serves as a bridge between GitLab.com and our downstream systems like Zora and Salesforce. And then we have all these other systems around the edges who need to provide data or fetch data out of these single source of truth systems in order to operate. And the problem with this architecture is that point-to-point integrations get really complicated, and they can be super unique. The way that each individual system talks to another system might be totally different, use totally different protocols and transports, and might have extremely varying levels of monitoring and support. And when these systems end up on a critical path for a customer experience, like a customer being able to buy a subscription from us, that can be super critical to the experience that the customer ends up having. So it's super important that we have good practices around integrations in order to have great customer and also employee experience as well. So let's talk about integrations patterns very quickly. So we've seen this one, the point-to-point integration. Generally, when we want to take this on as an integration team, we turn this into the buffered point-to-point integration, which basically adds some messaging service in the middle, which buffers these data communications that happen between the systems, allows us to perform retries and that kind of thing to increase the stability of these systems and make it easier to support them. Then we see the push fan out, where a single source system like System A has to send a lot of data out to other systems, B, C, and D. We do a similar thing here. We add a buffer, which allows us to have the retrying, same as the buffered point-to-point. But we can also actually take data from multiple systems, so systems A and E, and create an enriched data model, which can then be pushed out to systems B, C, and D, because it's not just one single source of truth system we actually have lots of different single source of truth systems for different types of data, and we might need to combine those before we send them out to different systems. This also allows us to support different transport types that potentially System A didn't support out of the box. So some downstream systems are older style systems. They only support FTP, or they might support SOAP. So we're able to provide different transport support for downstream systems. And then the last one I want to look at is the facade API, which is basically the same as facade pattern within object-oriented programming. Basically, you hide the complexity of downstream systems and APIs, and also the business logic to interact with those systems and APIs behind a facade layer. In this case, it would be a facade API, which means that system A, which might not be one of our systems, it might be an external system, can interface with downstream systems without having to understand or know the complexity or business rules to actually interact with those systems. All of that logic can be encapsulated within the facade and be very well tested as well. So let's talk about the platform and technology, which is Platypus. So what's a platypus made of? Well, a platypus is made up of some of the best characteristics of other animals on Earth. So it has a bill and webbed feet like a duck, which helps it in the water. And actually the bill is, it has a bunch of electroreceptors on it, which allows it to do electrolocation underwater. It doesn't actually use its eyes underwater to locate prey. They also have a tail like a beaver, and the male platypus has venomous spurs on its hind legs to top all of that off. So like a platypus, our integrations platform picks the best features of different tools to create boring solutions to common problems that we face at the company. So we've picked two tools for our integrations platform, Nest and Workato. Nest is a backend code platform written in TypeScript. This allows us to have flexibility. We can write custom code. We can do unit testing. It provides us a lot of the queuing and retrying infrastructure out of the box that we are looking for. And it has super rich toolkits for creating APIs that are versioned, that support different types of transports like we spoke about before, and also security practices as well. It also has no-nonsense conventions. We don't have to keep making decisions about the architecture. It's something we can just roll out the same way every single time. And probably the best part is change management, which is all done through GitLab. It allows us to have very good SOX controls, and also gives us a level of assurance through those controls and DevOps controls that we have on GitLab. And then Workato is an integrations platform as a service. It has a lot of out-of-the-box app connectors for common applications used in the enterprise space, including ones that we use. It has a lot of community-authored integrations for common workflows. And it has a super easy-to-use interface, which means that we can train other people at GitLab that aren't necessarily engineers to actually use Workato and build automations for themselves from a select catalog of data, workflows, and connectors that we provide to them. So how does Platypus fit into the overall architecture of how we do things? So you might have an integration solution that you start with. This might be developed in-house, might be a vendor, could be anything. So what we bring along with Platypus and with the enterprise applications integrations team is expertise and out-of-the-box accelerator catalogs. So we have lots of pre-built connectors. We have microservices and APIs that we're building, and that catalog is growing every day. We have subject matter experts within the integrations team, and also within the broader enterprise apps and business technology teams that we can bring along. We bring maintainability, reliability, scale, and support through queuing and retrying, through integration support and incident management, automated testing for anything that is built on Platypus. We bring compliance through AppSec reviews, privacy reviews, and SOX compliance reviews. This is super important for us as a public company now. We need to make sure that all of this is very, very well done. And of course, we bring results. We can bring faster delivery through our out-of-the-box connectors and catalog of pre-built solutions. We can build reliable solutions that are easy to support. They have, your queuing and your retrying, good logging, all of the right architectural practices in place. They're boring solutions. And also they're compliant solutions. So it's going to be super important for us that we are focused on that for all of these important systems that we have at the company. So if we jump back to that earlier diagram, the purple parts are actually what Platypus brings. So Platypus is that middleware layer that brings an enrichment to your integrations out of the box, borrowing solutions, and just makes things easier to support and better. Same here with the Facade API. The Facade is Platypus. And just some quick high-level ones here. I'll see if I can hide my video. I'll move it. So key business processes that Platypus supports today are lead to cash, record to report in finance, and hire to retire in the people team. What Platypus does really well, Platypus makes it really easy to create custom integrations and make native integrations more robust. It automates manual processes. Custom APIs that we need to create for vendors are easy to do now with good security, good practices. And it makes simplifying complex multi-system integrations easy to do by acting as an enterprise service bus. And what is Platypus not? It's not a customer-facing UI or tool. It's not a replacement for the business functions of Customer.dot. But what it can do is add value in the integration side of Customers.dot. And it's not part of the GitLab product. So it's not something that we would ship as part of self-managed or to any of our customers. And lastly, I just want to go over the vision that we have for our integration center of excellence here at GitLab. This is very common in the industry to have a center of excellence for integrations. We think this is made up of 4 parts. 1, Platypus, the technology that we bring to build these solutions. 2, the expertise that the integrations and enterprise apps team bring for these systems and for these processes that we can roll out and help teams implement well. And then 3, the compliance aspect, having baked in review steps, making sure that everything is tracked properly. We have good audit trails. We're doing the right things for logging and incident handling and for all changes that are made to systems. And then 4, we have a vision to create a citizen developer program where anybody at GitLab can learn the tools of integrations, come and utilize some of the catalogs that we've built to be able to actually automate some of their processes within their team and within their jobs to be able to be more efficient, but also following all the same practices that we need to have for these integrations at GitLab. So thanks for watching. To learn more and ask questions, check out our integrations handbook. And also you can contact us on BD Integrations on Slack. We're always there and happy to answer questions. And lastly, please share this video with your colleagues and look out for info on the Citizen Developer Program that's coming in FY23. So thanks for watching.